Okay, for the second part of 1.3, we're still looking at how to draw conclusions from our study. And so I'll be looking at a couple more terms and some of the number terms that we're going to be using when we're looking at values. So we can say, okay, this value is about our sample. This value is an estimate of our population. Okay, and the first thing we're going to look at is parameter and statistic. Okay, these are looking at two different types of data, and it's what these values describe determine if it's a parameter or a statistic. Okay, parameter is going to describe a population. Okay, we usually are never going to calculate a parameter because we're never going to take all the information from a population. Okay, these are going to be estimates, and the way we get that estimate is our statistics. The statistic is going to describe a sample. So what we do is we take a whole bunch of samples, and with all those samples, we use that to estimate our parameter. Okay, so you may have a whole bunch of samples where averages, weights are all over the place, but then you take all those and estimate what our parameter is going to be. Now what you're going to be asked to do is decide, okay, is a number a parameter or statistic? So you need to read the probability, read the situation, and decide, okay, is this talking about generally all of our items, or is it looking at a specific group of our items? Okay, so if we read through this, the bottles of tomato ketchup that are filled at a factory contain an average of 14 ounces of ketchup. Quality control took a sample of 50 bottles and found the average amount of ketchup in each bottle is 13.6 ounces. Okay? So we have the 14 ounces, we have the 13.6 ounces. I want to know parameter, statistic, they both might be parameters, both might be statistics. Okay? So what I'm going to point out is that this 13.6, this is talking about just a sample of 50. So that is looking at our sample that we took, or at least one of our samples that we took. So that 13.6, that would be a statistic. The 14 ounces, okay, contains an average of 14 ounces of ketchup. This is looking at all of the bottles and generalizing, okay, if we go to this factory, overall, each bottle is going to have 14 ounces. That's considered a parameter. Okay, reading through this, Pennsylvania, California flight, 8% of the 125 passengers had their bags checked. Security states that they randomly select 10% of their passengers to have those bags checked. Okay? So 8%, 10%. That 10% is what security is saying about all passengers. All the passengers that come through that airport, they say 10% are going to be checked. The one sample of 125 passengers, that was 8% of them were surveyed. So since the 10% is all passengers, okay, that would be our parameter. It's talking about all of our passengers. The 8% is talking about just that group of 125 passengers. So that 8 is going to be our statistic. Okay, so here we're looking at a research done on ducks. Okay, what it says is the university put 4 ducks in each of 4 plastic boxes, which were arranged in a row. Ducks in the 2 end boxes slept with one eye open 31.8% of the time, compared to 12.4% of the time for the ducks in the 2 center boxes. Okay? So our population here is all ducks. We want to know, how do ducks sleep? Do they sleep with one eye open, yes or no? And what it ends up is, out of the 4 that we had, the ones that are in the middle only sleep with one eye open 12.4%, compared to the ones at the end, 31.8%. Both these values are talking about our 4 ducks in our study. Okay? Neither of those numbers are talking about all ducks. So this ends up being both the 12.4 and the 31.8 are statistics. They're only talking about that small group of 4 ducks that we're looking at. So both end up being statistics for this example. A study was done on college students who injured themselves intentionally. Researchers invited 8,300 undergrads and grad students from Cornell University and Princeton University to take part in the study. A total of 2,875 students responded, with 17% saying they had injured themselves intentionally. So some questions about this. Observational unit, the variable type. Okay? The observational unit here, we're looking at students. I'd like you to get as detailed as possible. We're looking at undergraduates and graduate students from Cornell University and Princeton University. So our observational unit is each student who responded that was an undergrad or graduate from Cornell or Princeton. The variable that we're asking about, okay, we're asking, have you intentionally injured yourself? Okay? So have you intentionally injured yourself, and that type would be a categorical data, and I would say it is binary. It's either yes, you have, or no, you haven't. Okay. Population sample size is the 17% parameter or statistics. Do you think this sample is a good representation of the population of all college students? Okay, so let's start with the population. Our population that we sent out, we were looking at undergrads, graduates from Cornell and Princeton University. That was the population that we were able to survey. Okay? The sample was the 2,875 graduates and undergraduates who responded from Cornell and Princeton. Okay? So the people who responded, that's what our sample is. Sample size is a value, that's the 2,875. Is the 17% a parameter or statistic? Well, in this case, that 17% is talking about just the 2,875 students who responded. So that 17 would be considered a statistic. It is looking at just the sample that we got. Okay? And do you think this sample is a good representation of the population of all college students? So now I want to know, if our population, beginning of this study, was all college students, is this a good representation? Okay? So our sample was undergrads and graduates from Cornell and Princeton. I'm hoping we can agree that Cornell and Princeton, they're not your average schools. They are a higher level. Okay? They are some elite schools to go into. So is this representative of all college students? I would say no. If you want it to be all college students, you would have to randomly take students from all levels of colleges, from community colleges, 4-year colleges, 2-year colleges, okay? And also some of the elite schools. Then you can say it's of all colleges. But because we just had those 2 schools, I'm going to say no. This is not representative of our population. Our sample is not representative of all college students. Okay? 2 types of variables in every study. Okay? The variable whose effects you want to study is the explanatory variable. The variable that you suspect is affected by the other variable is the response. So we have what we think is what the treatment that we're looking at, the effect that we are putting onto our observational units. That would be the explanatory. And we're going to see, okay, how did this explanatory change our observational unit? That would then be the response. Okay? So the explanatory, it's not always something physical that I'm doing to someone. I just might say, okay, different types of classes students are in. And I'd observe them in a history class, a math class, an English class. That explanatory would be what class they are in. Okay? So it's not something I did to them. It's just the situation that they're in at that time. That would be the variable about that observational unit. Okay? The response variable is the final measurement that we're looking at. Okay? So here's the example. It has been reported that eating candy will make you live longer. A study was done in 1988. Researchers sent questionnaires about their habits and candy to men who entered Harvard University as undergrads between 1916 and 1950. They then waited and collected all death certificates of those who died by the end of 1993. Okay? So I'm asking you, what is the explanatory and what is the response? Okay? So, observational unit, explanatory and the type, response and the type. So now we're going a little further with these variables. We're adding some more terms to them. The observational unit, again, try and be as detailed as possible. Okay? We are looking at men who entered Harvard as undergrads between 1916 and 1950. If the study is explaining it in detail, try and be as detailed as your answer. It is each person or each man who answered the question who were Harvard undergraduates in 1916 to 1950. The explanatory variable. We are looking at their candy habits. That is what we think is going to affect their death certificate that we're looking at here. Okay? So the explanatory here would be eating habits. Now it's not too detailed about what type of question they might ask. Do you eat X amount of candy per week? Yes or no? Okay? They might ask, how much candy do you eat per week in ounces? Okay? So depending on how they collected this would depend on the type. Okay? If it just says you eat this much candy every week, yes or no, that would be categorical binary. If they say, how often, how many times a week do you eat candy? That would end up being quantitative because you're saying I eat candy 3 days a week. 2 days a week. The response also isn't quite that clear. What they did was collect all the death certificates. So they were measuring what is your lifespan, or how long did you live after you had that candy habit. So again, the type of data would be a little tricky to answer for this if you're not 100% sure how they collected that data. Okay? So here's the explanatory response. What we're looking at, what we think is causing the response. Okay? So try and think about what those two variables are when you're looking at studies. Okay? And what kind of study was the candy study? This was considered an observation. This is passive data collecting. We did not influence our observational units. We had our Harvard undergrads from 1916 to 1950, and we didn't say, okay, you have to eat this much candy every week. You are not allowed to eat candy. Okay? This was passive data collecting. We did not control the experimental unit or the observational unit. We asked them, they gave us answers, and we took that and made some relationships with them. Okay? The important thing about observational studies, you cannot have a cause and effect conclusion. We can say there's a relationship. We can say that, okay, these people ate X amount of candy, their average lifespan was here. People ate Y amount of candy, their lifespan was here. We can have that relationship, but we can't say the cause of their lifespan is just from our explanatory, the candy habits. Okay? And the reason for that is we did not control anything else. We did not control how much candy or anything like that. And now you have to worry about something called confounding variables. Confounding variables, a variable's effect on the response variable, are indistinguishable from the effects of the explanatory variable. There are other things that affect a person's lifespan. I think we can all agree with that. Okay? And what you would have to think about is what other variable could be affecting both the explanatory and the response. Okay? One example for this could be a person's exercise habits. Okay? Usually someone who is going to be exercising a good amount, they're a little more health conscious. So that exercising habit as another variable will affect both the explanatory and the response. Okay? If you are someone who exercises, and this isn't for sure, but we can say there's a good chance that that person with good exercise habits also has good eating habits, which means they probably don't eat a lot of candy. Okay? So those people with high exercise probably have lower candy habits, lower eating intake, candy intake. Okay? And those people that are exercising more, they're probably a little healthier, so they are having a longer health span. You exercising more is going to help you live longer, help you live a healthier life, so you are going to age more, age better, and in a more healthy way. So that exercising more is a confounding variable because we did not control that in our study. We only looked at the candy eating habits. This is also going to the exercising is something that also is affecting our explanatory and response. And that is something that an observation does not control compared to an experiment, which we get in more detail what an experiment is and what you have to do to have an experiment. So that is the end of 1.3. Again, there's a lot of terms, so make sure you're going through these notes, seeing what words we're going to be using throughout the rest of the course.